Hello YouTube! What I've got here for you today is an old Keithley Instruments 160 digital multimeter. It's a metal box with, I hope, a lot of interesting stuff in it. Especially these old neon tubes you might be able to see behind this plastic shield. They are Nixie tubes. So this is especially a stylish instrument with red glowing numbers if we can get it to work again. I found this on the local flea market, so fingers crossed it will work. But at least I think we'll need to exchange the capacitors because this multimeter is very old and it might have not especially leaky, but capacitors inside which will not be in very good condition anymore. So let's just start taking this beast apart. We have two screws on this side. Two screws on the other side. And I think now we are in like Flynn. Oi, I didn't expect that. So we see nothing but a big circuit board from its back. I think there are two big fuses behind here and some potentiometers are reachable from behind, but the rest of it is a little bit hidden. But at least we can see inside from its sides. Okay, I see some big capacitors and a lot of resistors, and I think especially a lot of resistors that have very high quality and very high very low tolerances. Oh, I start to see some digital circuitry. Okay, how do we get all this stuff outside? So I don't see an obvious way to open it. How to get its components outside. It might be that we have to take off these two screws on the front and maybe these two screws on the back. But how is the rest mounted? Okay, we might also need to get rid of the switch. Oh, the power switch is very small and has a very thin wire. I'm wondering how this can turn on the multimeter, or if it's just a kind of an enable switch, perhaps only enabling the display and not even the multimeter. On relay to turn on the power supply. I don't know. Let's find out. So let me just try to remove the most important screws. to get these metal frames out there and remove the I think not only the main PCB, I think with removing these screws I will get the whole unit out. It's only on these 4 screws. And the front panel button. That's an interesting construction. Okay, stuff is getting loose. Oh, but I still need to remove the button. So there's a small little grub screw in here. Far enough. Oh, it's not moving. Oh, there's another one. 2 little screws. That worked for me. Okay, this is a plastic shaft. I might be able to remove this further because there is a little grub screw inside this plastic piece. Okay, that screw is out, nothing is moving. Might be that there is another screw on the other side. So let me just move the switch. No. Okay. At a 45-degree angle, there's a second screw. Can I get it out? Yes. Okay. The button is removed. So now everything, as you see, can move freely. So I'll put the device upside down, then try to get the case off. Aha! Okay, the cable of the power switch is in the way, but I think it's socketed. So I can remove this connector. And we are good to go with the case. Nice. So this is the Keithley Instruments 160 in its full glory. And I see the first problem. I don't know if you can see this, but this capacitor has a huge crack in there. So maybe can give you a closer look. Focus. Yes. This capacitor is in a really bad condition. It's completely cracked from top to bottom. Focus. So we'll need to get it out there. and replace it with a good new healthy capacitor. So let me just try to get the front panel disconnected. The cable, so there are two cables going to the positive and one going to the negative connection. So the because the cables are soldered directly to the board, I'll just try to get the cables disconnected from the connector because they're screwed, and I'll just remove the screws if I can. And then we'll have the front panel completely disconnected from the multimeter. So these are the insides of the Keithley 160. There's a board with the Nixie tubes on it. There's a second board underneath this board, and there is some board behind everything, and a big switch arrangement. This switch is strangely loose, so there's an inside part of the switch. That's this one. And there's a part on the back panel. And these two parts are loosely connected, so the screws that hold together these different stages of the switch and in the PCB of the back switch, but they are not screwed in tight. So the whole switch arrangement can move inside there. Strange. And also I think just this nut in the front got loose. That may be also responsible for the switch wandering around so much. So I just tighten it down a little bit. Now a little bit more, and it looks like the switch isn't moving a lot anymore. So that just came loose over time. But maybe I just want to get the switch out of the way. It seems that it is connected via this cable harness and the connector on the board. So I can remove this connector. Maybe. Oh, it's tied in there. Yeah, but it came free. And the big cable here is just going to... Oh, not only. I thought it was only going to this backplane switch, but one of the wires is going to this staggered switch. So I won't be able to get it out completely without soldering. And also it's a little bit clamped between this PCB and this angle plate here. So I just might want to disassemble or unscrew this right angle metal plate. Oh. These screws are still tight in there. They didn't come loose. So here the switch goes or doesn't go. Okay, it seems that I have a little collision between this last part of the switch and this resistor on the board. The black resistor you might be able to see behind there is a little bit in the way, and I don't want to flex this back PCB too much, or the soldered connection might break loose. But I'll try. I'll try a little. Oh, it's not nice. Oh. Yeah, okay, got it out. Oh, and there's a small little single connector going to the backplane. I might have just bent it a little. Ooh, doesn't look good for that resistor. I might have mangled it a little bit. Ooh, scratches, scratchy scratch. Okay, that's not too bad. Not nice, but not too bad. Okay, let me just try to get these PCB out, these two PCBs, the top one and the middle one. For that I'll need to remove this plastic clamps. Okay. It's a little bit under strain. Okay, am I able? No, I'm not able to. There is still a screw with a couple of metal spacers going through both PCBs into the bottom PCB, so I'll need to remove that too. Let me just grab a screwdriver. There it is. No, I think the nut is turning with. Nut off. Screw out. And I'm not hearing the standoffs falling around, so the PCBs are still clamping in place. Oh no, it's still going through them. Can I remove it? No. How is it in there that it's holding in so tight? Can I lift it out? No. Okay, wait a second. So this kind of a riser PCB is not soldered to the bottom PCB. Focus. It's put inside of a board edge connector, so we might be able to remove it just by lifting out. So let me try that. Okay, it's a lifting. So we have here the bottom PCB with a couple of trimmer pots. a couple of are these transistors? So the two metal cans with heat fins seem to be transistors, but this metal can is a little bit more complicated. It has a lot more pins, and it might be okay, please focus. It might be that this is some of a kind of an IC, or it might be an operational amplifier, I think. There are a lot of old and interesting transistors on here. So these are your standard, well-known transistor packages, but behind them is ceramic, are two ceramic packages. Can I get them in focus? Yes. Two ceramic packages, and behind them are two metal cans. So we have a lot of different transistor packages on this board. Transistor and IC packages. Like this one will be an IC. And on the board behind, there's a standard dual inline package IC, but like you might be able to see, although they have gold covered leads, so there's a lot of gold contacts in here. I didn't expect that. Okay, let's go further with what I would call the main PCB arrangement, or perhaps just the most interesting, because it has these nice tubes. Focus, please. Yes. This nice vintage. How are they called? Nixie tubes on the board. So they are used to display the numbers. I hope they are still working, because the contacts down here, they look a little bit corroded, and they also look a little bit suspicious, like they might have leaked gas or moisture inside the tube. So if that happened, they are clearly dead, but maybe you are lucky. Are they socketed? They look like socketed, but I'm not sure. At least they are not moving, so I'll try not to break them. There are a couple of transistors on this side. They also look a little bit suspicious. They look a little bit corroded. Don't know if that will be a problem. This follow focus is killing it today. Not working very great. A beautiful board. A lot of really old transistors and ICs. Okay, let me just try to get the backplane off. Or get this rod out. How is it? Okay. So it might just be that I... how can I get this off without breaking it? Whoa. It's tied in there. So I moved the bottom PCB a little bit, and you see the rod is on an angle now. And I'll just try to move the top PCB now a little bit. Okay, then the bottom PCB. Okay, let me get this out. Yeah, okay. Got it. Oh, there's even a small dual inline package on this riser card. Interesting. Don't know that number. But when I look at this date code, is this really the 18th week of 1970? It looks like. Okay, I lost my focus. I can't control focus anymore. So I'll need to fix that. Give me a moment. So after having a lot of trouble with my camera equipment, I'm back. And I looked a little bit closer to the board, and there really is a printing on the board marking that it's from the 1970s. Interesting. I didn't expect this device to be that old. I expected it to be old, but not that old. And there's the IC markings in all of its glory. 18th week 1970. That's interesting. And I also checked what these small devices here are, and that are only link wires. They are partly insulated, so they look a little bit like capacitors, but they don't have any marking. And I measured them, and every one of these devices is a dead short, so it's not possible that they are capacitors. And also you can see these two connectors. The bottom one is fitted with connections on both sides, and the top one only on one side. That's something I've never seen. And also the drillings and the pads on the PCB reflect that. So this is a 2-row connector. That's a single-row connector. Okay, so far so good. Let us come to the other two PCBs. So now I can take them apart. It's interesting how this small aluminum rod is really tight, fit into the board. So I can wiggle it a little bit, but it's not moving up and down when I press on it. So also on this board, there's a small, even 17th week of 1970, 16th week, sorry. Small little dip package, a couple of metal can ICs. I'm only guessing that from the number of pins they have. Please focus. So they have 2, 4, 6, 8 pins, and not only 3 like a normal transistor would have. Okay, you can see that the traces are really nicely laid out. They look really really natural. They look really like grown, like something that comes straight out of nature. But they are only laid out by hand, because back then in the time you didn't have computers and digital programs to design your PCBs. They were hand drawn or laid out with a kind of a sticky tape onto a big sheet of mylar, so they could be projected down onto a PCB and then produced. Oh, I think there has been some botch here. Is it a botch or is it just a fix of a broken PCB? Because there are no pads and there are drillings down to the PCB, and they are just hand soldered to tracks. So the wires of the component are just hand soldered to the PCB tracks. So what's on the other side? On the other side is a transistor, this little transistor. So was it an afterthought? So I see that these two legs of the transistors are hand soldered and are just bent to reach a track. And this one, the third one, not. So that looks like it had a genuine a pad on the PCB. So maybe the PCB was just had just a manufacturing defect, and they just added the just repaired it. I think they just repaired it. They didn't add an solder pad to it, but they repaired the PCB on this place, on this position. I don't know exactly, but it looks like. Oh, and that's interesting. So there are a couple of components here, a transistor to capacitors and another transistor, that are on one side not connected to the PCB. Please focus on that. I think it's in focus. They are not connected to the PCB, but they are connected to a little metal insert that is in a small, I think, a Teflon sleeve. You can see it on a back side of the PCB a little bit better, I hope. And I think that's to reduce the currents that flow on the top side of the PCB, or charges that are trapped on the PCB. So it may be that this is kind of an sensitive circuit. Really interesting. They are just directly soldered together. So this is the interesting Nixie stuff. There are a lot of dip packages on here. I think that are mostly logic ICs. Then there are ICs that seem to be connected directly to the tubes, and they are socketed. so I think they are socketed in case they break, because they are connected to high voltages when they drive these tubes. Yeah, and there you can see the markings on the tubes if the camera focuses. Yeah, nice tubes. From made by Raytheon in the USA. Interesting. I don't know my tubes manufacturers. And on the front panel, there's a small little tube that's for the 1. So with this digit, you can only show a 1 or not a 1. And the 3 Nixie tubes can display numbers from 0 to 9. And then there is also a display with which can show a plus or minus sign to show you the polarity of the signal you feed into the instrument. Okay, I think that's it with this board so much. A lot of beautiful ICs. So it seems there are 2 possibilities. This device has not been made in the 1970s, but or not been made in 1970, but in 1971, because this IC here is a little bit younger. This one here too, but okay, these 2 ICs have the same numbers, but they have different casings and different production dates. So it might be that they have okay, this is still kind of a ceramic package. It's still a glued together package. I don't know if I can show you that. Please focus. Please focus. Okay, this is still a glued together package made of 2 layers. The package behind it. Please focus. What's going on today? Okay, there you can see these 2 packages very well. They are glued together. They are ceramic packages, but they are of different styles. And they are younger. The package behind it is a plastic package, but it's older. So it might be that these 2 ICs have been replaced when this instrument needed service, but I can't be sure. I really can't be sure. Also, is that a production date on these tubes? You see this number? 703509, 701808, 171808. So it might be that the outer left tube, or from the front the outer right tube, has been replaced. It's younger. It's from the numbers on the tube. It's a CK 1916 that are all of these 3 tubes. So they are the same model of tube, but they have different production dates. So maybe something broke on this board before and has been fixed. Completely out of focus. On the back side, nothing special. Okay, maybe there has been a little bit of modification or repair being done. I'm not sure. Something has happened there on this edge. But it looks only like a little bit of repair has been done. So let me just get to the last daughter board. How can I get it out here? Just pulling. Okay, that's good. So get the rest out of the way and focus on this board. So this seems to be some kind of analog stuff. There's a trimmer pot on there. There's a special cable which brings signals from here to here or vice versa. And again, here's this strange construction of small metal pieces where you can solder your wires or components on that are insulated with a, I think, Teflon sleeve and put through the PCB. And also these two transistors, they are connected. They are somehow connected together. I think that's to thermally couple them. So I think this is some kind of a special amplifier. I think the analog circuit designers could tell us more about this construction. But I'm really sure this is a specially optimized amplification circuit. Also, these transistors have 4 legs, not 3. And to top this up, there's some component, I don't know, on the back. It just may be to shield the connections under here, but it looks like there's a little bit more to it. Because there's this this focus, please focus. There's kind of a plastic part, a Teflon part behind the PCB, between PCB and this aluminum plate. And the aluminum plate is connected to the PCB via this trace. Interesting. It's a really special construction. And there's a screw of this metal plate. So I can see a little bit of glue or something else between the PCB and this plastic piece. I really don't know what that is. Is this glue or is this something leaking? I can't tell. But it seems to be just glue, okay. Seems they had to protect these 2 transistors in a very special way. And again, some really old ICs. And I just didn't notice before, there are a lot of capacitors on this board that don't have the common numbers marking, but they have the really old style, a little bit looking like a B color marking. So for these capacitors, the value was marked with colors. And I think the one here with the red top looks a little bit suspicious. On this side, there is, I don't know if I can show you that. Oh, I'm zoomed in to the max. And I can't get closer than this. But on this edge here, there seems to be a little bit of damage on this capacitor. It looks like it had started to crack. So maybe, I don't know if it's only the coating or if it's the capacitor itself, but maybe we need to replace this capacitor too. I'm not sure. Oh, and I didn't notice there's also a little potentiometer on the back side. I think this one is reachable from outside of the machine. Maybe. I'm really sure you can reach it. Yeah, that lines up. So you have these two that can be reached through these two holes. And you have the third one on the back. Is this in focus? Third one on the back. And the hole for that has even a small cover. So I think that's meant to not be easily reachable, but also be easily reachable, but not be reachable by accident. So let us take a look at the back. Okay. DC balance. So the small metal potentiometer is DC balance, and the two plastic ones are, is this the correct orientation? Yes, it is. So this gray one is offset current adjust, and the black one is ohms calibration. So you can calibrate the zero offset of your multimeter. But the DC calibration is covered by a small metal piece, so you don't accidentally adjust it and have your and render the calibration of your multimeter unusable, because you just turned the potentiometer you shouldn't turn. So back to the main board. This is the main board of the whole instrument. There seem to be some special resistors down here. Special because they have a low tolerance of only 1% on these two here and 0.1% on this one here. But it's not only the resistance that matters, it's the temperature coefficient. So I would guess that these resistors here have a special temperature coefficient, so they are really stable in their value on different temperatures. So on the back of this PCB, it seems to be that this is the power delivery part. So there are two big fat diodes under the transformer, another one here, and a bridge rectifier here. There are a lot of capacitors with the one that's broken. Yeah, that is the split capacitor. Interesting name. A couple more of capacitors. So then there is a transistor, which will be used for voltage regulation. And there is a really old socket of a standard that I don't know. So this is the power socket for 230 and then 120 volts. You can select this with the switch, and the function of the switch is described on the backplane. And then there's another connector, which I don't know the function at the moment. Might be. Let me take a look. There's the backplane. So, it's upside down. There's the power connector, AC power. There's the voltage selector switch. There's an output. I don't know. So this is an output, but I really don't know where it is for. Where it is, what use it has. I don't know if it's a digital or an analog signal. There's a 0. I think that's the potentiometer here. That's to zero out the instrument. And there's this nice switch where you can select if the out or the input of the instrument is grounded or floating. But I've taken a look inside of the switch and it's very dirty. So that would need a good clean. And that describes it. There's analog out directly written to the PCB, and the connectors wired in on the other side. So the output on the back panel will be an analog out. I don't know what is the scaling, but I'm sure someone could use it. A digital multimeter with an analog out. Interesting. Didn't know that something like this existed. And there are a lot of interesting markings on the PCB. Down here, a clock signal. Didn't know that this instrument would need a clock. Okay, might depend on how the logic and how the analog to digital converter is built. If it's how is it called? An delta ADC, it would need a clock. I don't know if every construction of ADC needs a clock, but there are certain types that do need a clock. And you can adjust that. You can adjust the 15 volt range, you can adjust the 100 volt. I don't know if it's the range or if it might be the range. So these are 10 volt, 100 volt, 1 kV are clearly ranges. But the 15 volt here might be the supply voltage of 15 volts. There's 3.6 volt line here. There's the 15 volt line here. Interesting. Ground slope and a signal that's just called A. One volt calibration. So the calibration potentiometer seems to be on the other side. Yeah, it's here. So there's your 1 volt voltage range. So I think that's it for this teardown. Next up would be trying to fix the capacitor. I'll need to order new parts for that before, so it will take a while to get back to this video. And then I'll try to get this thing working again, step by step. We'll see. I think first up would be trying to get the voltage rails working, and then looking for the clock. I think that's generated somewhere here. There doesn't seem to be a crystal on the board, so it's not a very precise clock. It might not be needed to be very precise, but we'll see. I'll try to find out more information about this instrument, and then we'll try to get it working again. So I think that's all for today. Thank you for watching, and I'll see you in my next video. Bye. So let me just get to the last daughter board. This one here. Oh. Whoa! Ouch! There was a sharp PCB pin on the back.